Recording. Okay, so we are talking about circles and this thing called radians, which we very, very quickly, briefly talked about last time, that on your calculator, there is a setting that is different ways to measure an angle. So if you were to go into mode, it's the second one down. It says radian or degrees. Most of the time, or everything you've ever probably seen in the past has been degrees, but there is another way to measure an angle, all right, and it's radian. And these values really on your, as far as your calculator goes, the only reason or the only time that you care if your calculator is in radians or degrees is if you press these buttons, the trig buttons, the sine, cosine, and the tangent. Any other thing on your calculator will not care whatsoever if you're in radians or degrees. So you're not going to screw anything up unless you press the sine, cos, and tan, the sine, cosine, and tangent. Then you need to make sure that either you're in the proper, you're meant to be in degrees or you're meant to be in radians. Okay, so that's the only time that you'll have to worry about it. And we're not going to get to that for another unit or two or another class or two. So right now, your calculator is really not going to be messed up regardless of the mode that you're in. Okay, and we'll get there when we talk about it. When we get to the sine, cosine, tangent stuff, then we'll like, all right, let's refresh our memory and let's remind ourselves which mode should we be in. Okay, so all right, well, let's talk about this. So parts of a circle. So let's just make sure, just a quick refresher on what are some names, what are some things that we need. Very first one is that you have a center of a circle. So all the points on the circle are exact same distance away from the center. That's what makes a circle a circle. And that distance from the center out to any edge, anywhere along, is the radius. All right, if you cut all the way across, so basically put a radius connected with another radius, that is your diameter. So diameter is two radius put together. So it's always twice that. Or a radius is always half of a diameter. Okay, so those are some big ones. You're going to definitely need either of those two measurements to do a lot of the things that we're going to be doing in here. Circumference is like perimeter. It's basically the length all the way around a circle is your circumference. And then every once in a while, they may use the word semicircle. It's just half a circle. So if you're talking about a semicircle and you want the area, then it's half of the normal area or half the circumference. So it's just a name. It's not really a separate formula or anything for anything like related to that. Circumference, we're going to find the length around a circle. That's going to have a formula, and area are really your two things that you'll need. So to refresh your memory on that, here are your formulas that you definitely are going to want. Circumference of a circle. The formula for circumference of a circle is 2 pi r. And please use pi on your calculator, not 3.14, because I don't think it'll be accurate enough. You're going to want the actual pi button because you want all the value after the 3.14. So pi goes on forever, and that value will play a role of whether it bumps a number up or bumps a number down or anything like that. Okay, so make sure you use the pi button, not 3.14. So circumference, which again is the length around, it's like a perimeter, is 2 pi r. And then your area formula is pi r squared. So make sure you have those handy, or hopefully we'll do enough of them that they'll just start to stick and you won't need to refer to anything. All right, so those are the two formulas we're going to use frequently. Notice they both have a radius on them. So regardless of the information, such as they give you a diameter, I really need the radius. So I'm always going to take whatever the diameter is, turn it into a radius, and then I can do whatever formulas, whatever measurements they want me to do. Okay. All right. So with that, let's just find a couple measurements. All right. And then until we get to kind of to the donut one we got to deal with, where you're finding kind of an area of this, but not the donut hole. All right, anyway, so it says find the circumference to the nearest tenth. Make sure we know what we're rounding to. Read directions. Don't get something wrong because you're not reading directions. So we are going to the nearest tenth. And a diameter of 1.3. So if the diameter is 1.3, I really need the radius to it. So what am I going to do to find the radius if I ever know a diameter? And this is going to happen frequently. What do I got to do to know the radius? Because both formulas that I'm going to use have a radius in them, not a diameter.
Is it half the radius or half the diameter?
Half the diameter. So we'll take that 1.3 and we'll divide it by 2. So if you threw that in a calculator, you'll get 0.65. And that's what you need. So they want the circumference. So circumference is 2 pi r. Plug in your radius, and then just plug it right into the calculator. 2 times pi times 0.65. All right, so 2 pi times 0.65. All right, and they want me to go to the nearest tenth. So I'm going to this decimal. The 8 bumps it up to a 1. So we are looking at about 4.1. And then label. So a circumference is a linear measurement. So it's so many feet, inches, meters. It's not an area measurement, so we're not squaring it. So it is 4.1 meters. Okay, so hold on. I have a 4-year-old. I don't know. Cousin. All right, go have fun. All right, sorry. Okay, so it says, is that okay? So formula, just make sure you know the value, plug it in the calculator. Done. Hopefully, decently straightforward. Okay, find the nearest hundredth. So we're looking at 2 decimal places on that. You need to remind yourself of the circumference again, with a radius of 1 foot 9 inches. So 1 feet 9 inches, I'm going to have to either, well, we're just going to convert it into feet. 9 inches is going to be some fraction, some decimal of a foot. So let's make everything into feet, kind of the bigger measurement. So let's do a little math here. We got 1 foot 9 inches is 1 9/12 of a foot. Because 9 inches is 9 out of 12. And then so 9/12 is going to get us our decimal. So 0.75. So 3/4 of an inch. So 1.75. All right. That is our radius. So circumference is going to equal circumference is going to equal 2 times pi times 1.75. And just like the other problem, we're just going to throw it right in the calculator, see what the calculator gets us. All right, so 2 pi times 1.75. Can't see that. There we go. So 10.995. So that 5, or that 9 is our second decimal place. That's our 100th. What's the 5 do to the 9?
Makes it 10.
Makes it a 10. Okay, so how do we deal with that? You're getting a 10.995. That's what we round to. That's what determines it. So that 5 bumps that to a 10. How do I write that?
It's going to be 11.
So like that's going to be 11?
Yeah.
Yes, because if that's a 10, you'd have to carry the 1. And then now that becomes 10, you'd have to carry the 1. So it actually becomes 11. And then I don't know if my math lab forces you to still put the 2 decimal places afterwards. That you'll have to use one of your 3. I'd put it, and then I would assume they'd want it, to be honest, because it's asking you to go to the nearest 100th. So I would assume that regardless of what your decimals are, they're going to want you to go out to the 2 decimals. So, okay, straightforward, pretty good. Formulas, just plug them in. Okay, so to make it a little bit more challenging, we're looking to find a diameter of a wheel. The wheel's got a hole in it. So we want to figure out, not the diameter, we want to figure out the area of the wheel. And we want it to round it to the nearest tenth. They tell us a 15-inch diameter wheel. So there's the 15 inches diameter all the way across, and a 3-inch hole. Okay. How do you figure out the area of the wheel / donut? What do you got to do?
Find the radius.
Well, like before you even get into that specific, in general, how are you going to find the area of the kind of bluish, but not like the green? We want to cut that out of it. Find the area of the whole thing. So I call that the big. And we're going to cut out the area of the small. So I got to find the area twice and find the difference between. Okay, so the area of the whole thing is going to include that hole, but then I'm going to find the area of the small so I know how big that is so I can subtract it from it. Okay, so let's write down our information. So if we are talking about the big, we're talking about a diameter of 15, which makes a radius. What's half of 15?
7.5.
7.5. Okay, so if we're doing the area of that, area formula, pi r squared. So we're going to square our radius and then multiply it by pi. So pi times 7.5 squared. All right. And then depends on your calculator. If you have one of these, you can just put it in exactly the way it looks. You can go pi times 7.5 squared. Your squared button is right there, kind of diagonal from the 7 or up from the log. And there's your area. Now, if you don't have a graphing calculator, you'll have to do it in some steps. You're going to want to do 7.5 squared first, get an answer, and then you're going to times it by pi. That'll get it. Okay. Okay, hold on just a second. There you go, turn on. It's all on this. Yeah, okay. There you go. Hey, hey. All right, have fun. All right, sorry. Getting ready for swim lessons, so we're good. Okay, so multiply it out, but basically if you have a little bit of a more basic phone or a calculator, such as your phone, you're going to want to square the 7.5, the radius first, and then take that answer multiplied by pi. Get the same answer no matter what. All right, so 176.7, because we're looking to be rounding to the nearest tenths on this stuff. So there's your big. Small is going to be the green. So same stuff. We have a 3-inch diameter. Radius equals half of that, which is 1.5. And we need our area. Pi times 1.5 squared. So no idea. Plug it in the calculator. We got pi times 1.5 squared. So that 6 will make the 0 a 1, so 7.1. Okay. So find the area of the wheel. We're taking the area of the whole thing, subtracting out the middle section, the donut. So the whole thing is 176.7. We're subtracting 7.1. I don't know. 176.7 minus 7.1. 169.6. All right. So label though, that's going to be something on quizzes and homeworks and stuff like that. We want to label correctly. It's not just going to be there all the time for us. We were talking about inches, and you're talking about an area measurement. So you're looking at 169.6 inches square. That means, just again, to make sure we comprehend what that means when you're talking about an area, that means if you were to have squares that were 1 inch by 1 inch, and you laid them out somehow to fit it all the way in within that circle, it should take it, you should be able to get that accomplished with just under 170 of those little squares. Is the idea. You'd have to break off little corners to make them fit, but that's the idea. Okay. So hopefully it's still straightforward, because it's about to change. So any questions so far on the circumference and circle or area in a donut? All good? I'll take no news as good news. All right, so radian. This is your other way to measure an angle. Okay, so I'm going to do a couple examples. This is definitely something that I did at the very beginning of my trig class. Well, most of the stuff we do in their trig class is measured in radians, and some stuff is degrees, but we go back and forth all the time with it. So since we're getting into trig stuff, we also are being exposed to that a little bit. So here's the idea of what a radian is. So let me kind of go up to the top here. So a radian, just radians in general, is like a degree is where you 360 degrees is all the way around, and 1 degree is just a little tiny portion of that circle. Well, radians actually is more of a circumference. So you're still talking about all the way around a circle, but you're talking about a length rather than a degree of something. Okay, so it's a circumference of a circle, but that circle has to have a radius equal to 1. It's called a unit circle. Okay, so the idea is, and let me they have a nice visual for this, and then we're going to do some equivalent values here so you can comprehend what would be the equivalent version in degrees compared to radians. Okay, so here's the idea. 1 radian is literally you take a radius, that length, and you lay it on the circle. And so if you kept doing that, 3 radians would be like this would be 1 length kind of wrapped around the circumference, and then a second one wrapped around the circumference, and then a third one wrapped around. And if you kept on doing that, first they wanted to show you that the halfway point is pi. The biggest thing is because your circumference on this circle, if you have a radius of 1, that's the length all the way around. So halfway would be half of that. So divide the 2 in half. So halfway around, that length would be pi. And then 5 radians would be, here's 1 length, 2 lengths, 3 lengths, 4 lengths, 5 lengths. And if you go all the way around, it's 2 pi, but the decimal version of that is 6.28. So it would take 6.28 radius lengths wrapped around the circle to get all the way around. So here's where this goes. That means that 360 degrees is equivalent to 2 pi. That's all the way around the circle. That's all the way around the circle with a radius of 1. So if you were to go halfway around, that'd be equivalent to 180 degrees. That would be half of a circumference. Right? And then you can continue this. You had 90 degrees. 90 degrees would be half of 180 is 90, so half of pi is pi over 2. And then 45 degrees would be equivalent to half of this, pi over 4. And this thing could go on and on and on. And we're not going to get to some of the not crazy stuff, but there's a lot of relationships going on that we won't cover and we won't probably scratch the surface with that you would in a trig class. There's a whole bunch of relationships. But what we are going to talk about is how do you go from this 2 pi, like a radian measurement, to a degree measurement, or how do you go from a degree measurement to a radian measurement? And there's a nice little formula kind of for depending on the direction that you're going, all right, that we want to focus on, and that'll cover everything. So when they say convert something, this is what we're going to do. And so we have this couple examples down here. So let me show you your formulas for converting. All right, so if you go from radians to degrees, okay, radians to degrees, you're going to take your radian measurement, whatever it is, and you're going to multiply by 180 and divide by pi. That's it. That'll convert it. So if you had a radian of this, pi over 2, and you wanted to convert it into degrees, you would take pi divided by 2, and then you would multiply it by 180. So you can do it in steps. You can multiply it by 180, and then divide it by pi. And there's your 90 degrees. Okay. So I'd probably do it in steps to not screw it up. Well, it doesn't matter. You could also just put it in parentheses, 180 divided by pi. Okay, so that's the same thing. Okay. All right, if you go the other direction, you go from degrees to radians, all you're going to do is switch your formula around. Your degree measurement times pi, and then divide by 180. So if you had a degree measurement, 45. The problem on this one is you're not going to get this nice clean look. You're going to get a decimal version of it. And that's probably fine. But so it's not as straightforward as this. But you'll see, we're going to do a couple of them down here. Okay, so radians is just a portion of a circumference. That's all it means. It's a length. All right, it's still all the way around the circle is 360. Well, all the way around in circumference is 2 pi. Halfway around the circle is 180 degrees, so it's half of the circumference is pi. Okay, and this is a quarter of the way around, so it's a quarter of the circumference. So a quarter of that gets you that. Okay. All right, so let's do some conversions. So we're going to need to kind of notice what direction we got going on, and then we'll answer these questions. So we're going to take the degree and we're going to convert it into radians. So we're going degrees to radians. So we're going to multiply by pi and divide by 180. And we need to use the pi button. Again, not the 3.14. So you're going to take 20, multiply by pi, divide by 180. Just let the calculator do the work. So 20 times pi divided by 180. And we needed to go to the nearest hundredth. So that 9 is going to make that a 5. Point 35. Now, it's not a great answer because normally they have a pi on it, but it's basically like taking these types of answers and just getting the decimal version of it. Okay. So we kind of compare it to this length right here would be 1. So we would be at 0.35. So we wouldn't be very far, which is also not a very big angle. That's why it's 20 degrees. 175, we would be awful close to 180. So we're probably going to be, our answer for this is probably going to be pretty close to 3.14. I just don't know exactly what it is. So we'll multiply by pi, divide by 180, and let the calculator do the work. 175 times pi divided by 180. So it should be close to 3.14. And that 4 is not enough to bump the 5 up. So 3.05. All right. So 175 degrees is almost 3 radius kind of wrapped around. So it's really, really close to that measurement right there. Okay, going the other way. So notice how they label it this time, because like there is no little shortcut symbol on radians. So they just call it rad, 2 radians instead of this is a degree symbol. So 2 radians, we're converting it into degrees. So we're multiplying by 180 and dividing by pi this time. So we're switching our direction. And we're going to round to the nearest 10,000. So tenths, hundreds, thousands, 10,000s. That means we are looking at the 4th decimal place. Okay. So 2, we're going to multiply by 180 and divide by pi. So we want to round to the nearest 4 decimal place. So that 5 would make that 5 a 6. So 1, let me write it down what we did. We took 2, we multiplied by 180, divided by pi. 1.114, and then 5, 9, 1, 6. And then this is your degree measurement. Okay. This one, if you happen to remember, it's 90. But if you don't, that's okay. Because we are going to multiply it by 180, divide it by pi, and let it do its thing. So since it's a fraction times a fraction, I'm going to put the first one in parentheses. So there's my fraction times my other fraction. So 180 divided by pi. All right, so that gets us a 90 degrees. Okay. Okay so far? Any questions? Just kind of some formulas of what we got going on.
No, it all makes sense.
So make sure you guys make these things stand out, so you don't have to go and hunt them down and find them later. So it's just a different way, new way. It's a piece of a circumference rather than a small little degree measurement. But if you drew it, it'd be in the exact same spot. So, okay, that's good. Hopefully. We got one brave soul saying, I think we're okay. All right, last part of this is not crazy new. It is taking this degree measurement. So we're going to take 1 radian. We're going to convert it into a degree, and then we're going to use the feature on the calculator to turn it into the degrees, minutes, and seconds. The more of like putting it on a globe kind of a thing. All right. So 1 radian, and we're going to convert it. So it's really no different than this step right here. We're taking 1, we're multiplying it by 180, dividing it by pi, and that's going to equal probably half of that, because 2 is half of 1. Let's see what that gets us. So 1 times 180 divided by pi. No, I definitely don't need the 1, but so we are going to all right, so right now is not the time to round it. Let your calculator store all this stuff. So right now I'm looking at 57.295 ... Right, we got all sorts of decimals after that. Well, we want to not round this, but we want to convert the whole thing into degrees, minutes, and seconds. So that is that button on your calculator, degrees, minutes, seconds, with a little arrow on it. We just got to remember how to find it again. So to find it on your calculator, it is the angle kind of app on it. So right above the word apps is angle. So angle is going to take you into any kind of conversions or anything related to an angle. So we're going to click angle. Fourth one down is your degrees, minutes, and seconds. So that arrow is it's converting it into degrees, minutes, and seconds. Okay, so notice I didn't have to highlight. I didn't have to do anything like that. Basically, as long as I didn't press any number or any operation, it's going to automatically take my prior answer and convert it into degrees, minutes, and seconds. So it's going to take this 29.29, which is about a quarter, which is about 15 minutes, and then some change to it. And it's going to, so there's your about 15 minutes because it's about a quarter of an hour. And then, so now here's where we want to start to round. So here's your minutes, here's your seconds, and then they want us to round to the nearest second. So that 8 is going to bump 44 seconds to a 45 seconds. So we don't have to do the math. We just have to know how to get there on the calculator. The doing of the math is taking that decimal, not the 57, taking that decimal and multiplying it by 60, which would get you 17 point a bunch of things. And then you take that decimal and multiply it by 60, and that'll get you your. So unless you have a calculator, it's a lot easier. We just got to know where to find it. So 57 degrees, 17 minutes, and 45 seconds. Okay, let's do that one more time. 2.5 radians. So 2.5, first thing we got to do is convert it into degrees. So we're going to multiply by 180, divide by pi. It's going to get us some value with a bunch of decimals probably on it. So 2.5 times 180 divided by pi. Oops. Okay, so 2.5 times 180 divided by pi gets me a whole lot of whatever. So 143.239 dot dot dot. Don't lose any of the dot 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 stuff. And then you're just going to hit angle and convert to degrees, minutes, and seconds. So already I know it's going to be 143 degrees. That 0.23 again is about a quarter, so maybe it's going to be like 14 minutes or 13 minutes or something like that, almost a quarter of an hour. So angle, degrees, minutes, and seconds. So there's my 14 minutes. And then I'm rounding it to the nearest second, so it's 22 seconds because the 0 does not bump it up. And there's your angle. Okay. So hopefully you have a calculator that will convert it for you. Otherwise, it's going to be a lot more complicated. It's going to be multiplying by 60, multiplying by 60. All right. Questions on that last little chunk? That was okay? Okay. All right. Last, I believe, little bit of this section is, yes, I think, finding arc lengths and areas of sectors. So here's kind of the big idea of what's going on is you're finding, kind of give yourself a visual to this. So if you have a circle that kind of has a little slice cut out of it, the arc is kind of this chunk right here. That's called the arc length. And it's, I kind of call it the crust. All right, so it's a part of your circumference is what you got going on. And then this on the inside is what we call a sector. The sector is the area on the inside. not the crust. So it'd be like the pizza slice. Okay, so the area of the pizza slice is the sector, and then the crust is the arc. So you have a fraction of your circle. So you're going to see that the formula, the setup, the process is going to be crazy similar to each other. Either you have a fraction of the circle for the area, or you have a fraction of the circumference. Those are your two main ideas. So the approach is identical to both. You're just going to be talking about, am I talking about the area or am I talking about a circumference? All right. Other than that, not much is changing. So they have some formulas down here for you, but let's kind of summarize it. That if your equation is in degrees, because some of them will be in degrees, some of them will be in radians, that you're taking a fraction. First off, the letter that they have a tendency to use to represent arc length is S. Okay, and we have a fraction of their circumference. So to figure out this fraction, this angle, that's called theta. Theta is a symbol that typically represents a missing angle. It doesn't have to be theta, it could be an X or whatever, but typically when you're missing an angle measurement, we use that symbol to represent that, and it's called theta. But you're basically taking, theta is going to represent a fraction of the circumference, or fraction of the circle. So your fraction of the circle is how many degrees out of 360? So if it's 90 out of 360, you're looking at a fourth of the picture, fourth of the circle. 120 degrees is a certain fraction of the circle. So it's a fraction of circumference. That's your formula. So then you'll just plug all that stuff in and get yourself your arc length. The only difference is when you're in radians, when you're going to do your fraction of a circle, it's still your angle measurement, but it's out of 2 pi, because 360 is all the way around in degrees, 2 pi is all the way around in radians. But otherwise, it's still circumference. So a fraction of the circumference if you're in degrees, fraction of the circumference if you're in radians. All right, so here are your formulas. And that's the same, basically. Okay. All right, so it says find the arc length of a sector formed by a 60-degree central angle. The central angle is kind of that middle one that we talk about. We have a picture for. So you got a 60-degree central angle, and the circle has a radius of 30 millimeters. So picture-wise, let's say that's 60 degrees. The radius is 30. And we want to figure out the arc length. So fraction of circumference is what we got going on. So there's our 2 pi r. Fraction of the circumference is 60 degrees out of 360 degrees. And I can just put all that right into the calculator. So it doesn't tell us what we're rounding to, which is not usually the thing on my math lab. So if they don't tell me, I always kind of just automatically do 2 decimal places. That's kind of my universal rounding. I treat everything like money. Money is your most common decimal, I feel like. So I make everything kind of a money-ish idea, just to keep everything consistent. All right, so I'm going to have that fraction times that circumference. So 60 out of 360 times 2 pi times 30. And we'll let the calculator do its thing. So 31. And again, like I said, if it doesn't tell me, I just go to 2 decimal places, so that 5 is going to bump the 1 up. And it is a circumference measurement, so let's label it appropriately as millimeters.
This is literally making my brain hurt.
I told you there's a lot to it. That's why we're recording. You can put yourself to sleep later tonight by watching it again. Okay. So fraction of circumference. We just got to figure out really the angle measurement. So to figure out your fraction, and then you got to figure out what the radius is. They give you the diameter, cut it in half, make it a radius. Okay. Now they give you this different formula for if it's in radians, but I don't like it because now I'm talking about a whole different thing. Like I think that's silly. So I'm still going to do the exact same thing that we just did. The only difference is when they tell me that it's in radians, I can't do it out of 360. I have to do it out of 2 pi. It's literally the only difference. Okay, so I won't have that. It'll be whatever my radian is out of 2 pi. And then the rest of it is all the same. Like I don't want to crazy change it, create a new formula, nothing like that. Okay. I want to keep the same consistency happening regardless of the situation. So it says find the arc length. So this to the nearest hundredth. All right, they tell us this time. So 100th is the second decimal place. The circle. So here's our picture. We have a central angle of pi over 3. So they don't give us the degree measurement. So that instantly tells me that it's going to be out of 2 pi. So that's my angle out of 2 pi. That's the fraction of the circle we got going on. And they give me a radius and a picture, so I don't have to draw it. So I just find out what the circumference is. So fraction of circumference. Now, good news. If you're comfortable, well, we'll do it on the next one. So let's just throw it in the calculator. We have pi over 3 divided by 2 pi. So here's a suggestion. Again, if you have a little bit of a newer calculator, you're going to probably want to go to this little F1 button, which is a nice, cool fraction feature. So if you have the newer calculator, well, it's not even that crazy new, but somewhat newer calculator, you may have that option. Otherwise, I'll show you what it looks like without. But you're going to have to do pi divided by 3 over 2 pi, and then times 2 pi times 2. Okay, so that's exactly the same thing. So fraction of circumference. Fraction of circumference. All right. If you don't have that feature, then you got to use your parentheses very carefully. So you want your fraction, but then your pi over 3 needs its own fraction divided by, so that's the top, divided by 2 pi. That's the bottom, okay, parentheses. If you don't do that, it will not work out correctly because it will divide by 2, but it will not divide by the pi as well. You have to have that in its own kind of separate parentheses, so it divides by the whole thing. And then I'll do the rest. 2 pi times 2. Same thing. So if you have that fraction thing, it's way simpler, way cleaner way of doing it. Otherwise, you're going to do a lot of parentheses. So numerator, its own parenthesis, denominator, fraction, its own parenthesis. Multiply out. Okay, we're going to round to 2 decimal places. So you're looking at 10.47. The 1 doesn't bump it up. And then label for this, it's not an area measurement. So we're just going to throw the centimeters on. Okay. There is a bit of a shortcut that I don't know if anybody saw it or not. You might be able to save yourself some headache with the calculator here of kind of all the parentheses and all that nonsense. There is a shortcut if you're comfortable with it. So it's fraction of circumference. These two pieces will always cancel each other out because this is multiplying by 2 pi and this is dividing by 2 pi. You can literally cross that out. And that, if it's in radians, now if it's in degrees, that's not much of it. That choice doesn't exist. But if it's in radians, you'll always have a 2 pi here and you'll always have a 2 pi here. So they'll always clean each other up. So really, what you'd have to plug into the calculator would just be those two pieces multiplied together. Get you the same thing. So if you do pi divided by 3 times 10, a little bit of a shortcut. Okay, if you're comfortable with it. If you're not, by all means, throw it on the calculator. Feel like you're getting that wrong, so that's okay. Just shove it all in. Okay. I think one last for this. So this one is, it says find the radian measure. So this time we don't know the radian. That value won't be known. But they tell you everything else. So it says of an angle at the center of a circle with a radius of 5. Oh, the radian, not radius. The radian measure. So that's your theta is what's unknown, your angle measurement, but it's in radian. The angle intercepts an arc length of 12.5. So the S is 12.5. So for your formula, because they tell me that it's a radian measurement, I'm doing this out of 2 pi times 2 pi r. And I plug in what I know. They give me the arc length. They don't tell me the angle. And they tell me the radius measurement. Now my job is to solve. But that little shortcut is there screaming at me, giving me the stink eye. So let me cross them off. That makes this easier. So now you're looking at 12.5 equals 5 theta here when you multiply those two together. Now that one little step of being able to cross off that denominator 2 pi with that piece right there 2 pi makes that way simpler looking. Now I just finished it with dividing by 5. I don't know what that is. 12.5. 2.5. And it is my radian measurement, so 2.5 rad. Okay. All right, so that was all the crust. That was all arc length. So the next chunk of this is not dealing with the arc, but dealing with the area within. Nothing is going to be drastically different other than your formula is not going to be 2 pi r. It's just going to be pi r squared. But other than that, everything else is identical, which is great. That it's not a brand new thing. It's just we're going to tweak the formula because they're talking area, and all the other rest of the math is going to be the same. Unless, of course, we have one last one. Not weird enough. All right, so we're looking at arc length. So let me kind of start by drawing out the formula. Let's talk about what we know, what we don't know. It says find the radius of an arc. So we don't know the radius of the arc length. Or sorry, of an arc if the length of the arc is 8.22. So that's your S value. And it is intercepted by a central angle. And that is your That's your radius, which we don't know. Our arc length is 8.22, and our angle measurement is theta. So it's 3 radians. So let me put the formula out. It's going to be over 2 pi because it's in radians. And it's an arc length, so it's circumference. So plug in what you know. 3 radians don't know the radius, but we know the arc length. Plug in what you know. Good news again. Those cancel. You're just left with 3 times r. And we finished by dividing by 3. And I don't know. 8.22 divided by 3. 2.74. Centimeters. Okay. So just formula, plug in what you know, solve for what you don't know. And when they go to area, area is a pi r squared thing. So our formula that we would be using would not be drastically different than this. If it was in radians, you would just have pi r squareds in there. So let me generalize our formula again. If it's in degrees, your area is going to be a fraction of an area. If it's in radian, it's still a fraction of an area. So then the only difference is degrees are out of 360, radians are out of 2 pi. Again, they're creating different formulas that I don't feel like. Why complicate this? Okay. So it says find the area of the sector. We're looking for the purple. So we're finding the area of that. They tell us our angle is 45. And we have a radius of 10. So let me add that in. Round to the nearest hundredths. So hundredths is second decimal place. So area is fraction, which is 45 out of 360 times pi r squared. And I don't have that nice kind of things cancel like we do when it's in radians. Like nothing really cancels. I'm not even going to try to figure that out. I don't care. It's just plug it in the calculator. So we have 45 divided by 360 times pi times 10 squared. So 39 point, they wanted 2 decimal places, 39.27. We're looking at inches, and this is an area measurement, so it's inches squared. Okay. So good thing, hopefully, is you're realizing that it's really not drastically different, just a different formula here, but it's still the same idea, same concept. It's a fraction of a circle, so it's a fraction of the area. The others were fraction of a circumference. I knew there'd be more. Okay. So 2 more of these, and then we go into volumes, which is something that you probably have seen. Okay, so last 2 of the sector things, and this one is just the last one's just a little bit more complicated, but not crazy. I know there's a formula and everything, but again, if we just kind of logic our way through it, I think it's not bad at all. So it says find the area of the nearest tenth of a sector. So remember that sector is an area thing. Area. Our angle is 1.6 rad, so 1.6 radians. So we're going to divide it out of 2 pi. And it has a radius of 7.2. Okay, so our formula since we don't have it here, it's fraction of area. Okay, so that's our formula. So they tell us the angle measurement is 1.6. So 1.6 over 2 pi. And then pi r squared. So that's 7.2 squared. Is our radius. There is one little cleanup that I can do. It's not as nice as the last one. We talked about circumference, the arc length. But that pi on the bottom can cancel that pi on the top, which might simplify your work a little bit on your calculator. So it really just turns into 1.6 over 2 times 7.2 squared. Is really all you got to plug into the calculator. So I don't know. 1.6 divided by 2 times 7.2 squared. 41.472. And it wanted me to go to 2 decimal places. So we'll cut it off at the 7. 41.47. Sorry, here's 10th. Scratch that. 7 makes it a 5, so 41.5. And we are talking about an area measurement, so inches squared. Okay. Let me pause for a second. Any questions on that? It might be a little overwhelming right now. Might take a little practice. But any questions, any clarifications, any, what the heck just happened? Okay. All right, last bit is we want to find the area of this piece, which is kind of part of this pie slice here, the sector. So this is very much the donut idea, that we need to find the area of the whole arc, the sector, and we need to subtract out the triangle. So we would have this left. Okay, so we need 2 things. So we need the area of the sector. Okay, so we're going to do the work for that. And then we'll need the area of the triangle. And we'll organize that over there. And then I just subtract the triangle away from the whole slice, pizza slice, and you'll have left that piece. Okay, so sector is, let's see, they gave us our angle in degrees. So it's a 90-degree angle. So my formula is going to be out of 360 because it's an angle. So it's a fraction of the circle. So 90 degrees out of 360. My radius is the 9.25. That's the radius. Like that. And since we don't have the pi on the bottom here, they don't cancel. So I'll have to just throw the whole thing into the calculator, get an answer on it. They want me to go to the nearest hundredth, so I'll start rounding things to the 2 decimal places as we go. So let's see, we have 90 divided by 360 times pi, and then the radius squared, 9.25 squared. The calculator to get all that for us. So I'm going to go to 2 decimal places, even though it's a 0, so 67.20. Okay, so that's the bigger section, right? That's the whole thing. It's 67.2. The triangle is I need a base and a height. So if you need to, let's redraw this triangle. with a base and a height to it. So that dotted line is the height, the 6.54, and the base is the 13.08. So it's kind of hard to see when it looks like that. So I don't know if it helps to turn your picture to where that's the base and that's the height, because they got to be perpendicular, or if you just need to just draw it again. But that's what we need. So 1/2 base, 13.08, times the height, 6.54. And I have no idea. Let the calculator do that. So 0.5 times 13.08 times 6.54. So I want to go to 2 decimal places, so that's 42.77. All right, and then the last bit is, this was the whole pizza slice that we need to cut a triangle out of. What we'd have left is this little kind of sliver of a piece. So our final area is 67.20 minus 42.77. I don't know. 67.20 minus 42.77. So 24.43. And you were looking at inches squared. Okay. That one does it now, I think. All right, so that's probably some new stuff going on there. And that's about as hard as they get when you have to find kind of this leftover piece. And they will give you enough information where you should have a length across here, which is always going to be your base. They should give you a dotted line, which is your height of your triangle, so that you should have everything you need in order to find the area of the triangle. You have everything you need to find the area of the whole thing, and then subtract the 2 to find the slice that's left over. Okay, so it's not meant to be tricky. It's meant to, can you extract the right information that you need? Okay. All right. Volume, surface area. Volume is kind of the space within. Surface area would be if you're wrapping paper around it. How much wrapping paper do you need? Volume is if you're pouring a liquid into something. Then you're talking about the space within. So we are going to find some volumes and surface areas. Now, to be honest, volume is actually much easier to find than surface area. Surface area is, if you do use a full-on formula, it's more complicated. If you don't, you just have to find the areas of all the sides, which I prefer that route than trying to remember another formula or anything like that. I just kind of draw pictures and figure out the areas of all my sides that I got going on. But a volume is a lot more straightforward. Volume is, on almost all of them, it's just the area of the base times the height. That's it. The only difference on every single one of these is what the shape of your base is. The shape of that base is a circle. The shape of that base could be a square, could be a rectangle. So that's the only thing that changes is your shape, which means how you find that area is different than how you find the circle. Or your base could be a triangle. Find the area of the triangle. So, but that's basically what you got going on. And anytime a shape has a top and a bottom, and the tops and bottoms match, then area of the base times the height. So when the tops and bottoms match, you're looking at cylinders and you're looking at prisms. Prisms are just three-dimensional shapes where the top and the bottom match. Could be triangles, could be squares, could be rectangles. The sides are the key, though, that makes a prism a prism. The sides are rectangles. The sides of this thing standing up are rectangles. The sides of this thing standing up are rectangles. That's what makes a prism, rectangular sides. Okay, so we got some formulas going on. Base times height, that's it. I wouldn't give it any different. Okay, I'm not going to specialize if it's a circular base or a square base. Like that all gets adjusted appropriately depending upon your problem. But if I just generalize as a base times height, that covers a lot of these shapes. Okay. So it says find the volume. So first thing I would look at is, does the top and the bottom match? If they do, then I'm looking at that formula. All right, so I know that I'm finding the area of the base times the height. What I don't know is the area of the base, it's a triangle, and I got to figure out the height. The height's pretty straightforward. There should be, but I don't know that. So let's draw a picture. Okay, they give us a little dotted line on there. That dotted line is right there. That is your height, 2.6. And then the side where it's perpendicular to is the 3. So your area of your base is 1/2 3 times 2.6. So if I throw that into a calculator, I get 3.9. So that's the area of that, which is the same as area of that. So area of your base is 3.9. Your height is 15. There it is. And then we throw that in the calculator. So if I throw in the calculator, I get 58.5. And then volume is always a cubic measurement, centimeters cubed. So that would be like if you are trying to see how many of these little cubes would fit into this shape, and each one of these things would be a 1 centimeter by 1 centimeter deep by 1 centimeter tall. So if you had little cubes that were exactly that, you should be able to fit 58.5 in this prism right there, is the idea. Okay, so cubic centimeters, cc's, heading in the medical field. People are heading in the medical field. Isn't it like 1 cubic centimeters equal to 1 milliliter? Something like that. I know I got some future ambulance people or ER people. 1 cubic centimeter, I think, is 1 milliliter of liquid. Something like that. Maybe. It's not my realm, but I think that's true. Okay. So there's definitely a relationship between a volume measurement and a liquid measurement. Now that's the metric system. We would maybe do more something ounces and I don't know. But all right. So that okay? Area of the base times the height. The base was a triangle, so we need to do a little side work for that, figure out what that area of the triangle was, and then multiply by the height. That is our universal. As long as your top and bottom match, that is your method. We're doing the area of the base times the height. So good thing they gave us a picture, but basically this is the description. It says, what is the cubic inch displacement, space occupied, of a cylinder whose diameter is 5 inches and whose height is 4 inches? So here's our picture. So if we drop that in water, it's going to take up a certain amount of space. That's the displacement that they're talking about. So we're trying to figure out how much space is it taking up. So our base is a circle. We need the radius of that circle. What is the radius of the circle?
2.5.
2.5, half of 5. So our formula is pi r squared. So pi times 2.5 squared equals pi times 2.5 squared. All right, now here's the thing. We want this to be as accurate as possible. So I don't want to round anything yet. Eventually, we're going to round to the nearest 10th, it says, but not yet. We really need to hold off that rounding until the very end because this thing is going to get multiplied by something else. That's the area of the base. So that 19.63 blah, 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 I'm going to keep the whole thing. I'm not going to round. I'm not going to do anything. Because my next part of this is the volume is that number, 19.63 whatever, blah, 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 times the height, which is 4. Where my calculator can handle that very, very simple is I can just go times 4. So it'll take my last answer and multiply it by 4. And now I can round. Because if I round here, I may make my answer too low. I may make it too high, just because there's this rounding within rounding, and it just kind of takes the rounding error more and more and more every time you round. So I want to hold off until the very, very end because my calculator will handle all that and store it all for me anyway. So why not? So we're going to the nearest 10th. So we're looking at the 3 does not bump the 5 up, so it's 78.5. And we are at cubic inches. Okay. Volume okay so far?
Super.
Super. Not bad. Could be worse.
My brain hurts.
You're welcome. I'm keeping you from Alzheimer's. That's good.
Oh, you know.
You're welcome.
We have how many 4 weeks left?
It's getting there. It's getting close. Yes. All right. So your other shape, there's 2 other shapes. One is a shape that comes to a point, aka cone or pyramid. All right. Both of them will come to a point. Right. A pyramid is going to have some triangular sides to it, where a cone kind of has a circular-ish shape to it in general. But no matter what, if it comes to a point, your formula is still base times height, but now you just take a third of it. That is literally the only difference between them, which is good. It's not crazy different. I'm still going to find the base, which is the bottom. So again, it could be a square, it could be a rectangle, it could be a circle, depends on the shape. And then we're going to multiply it by the height, and then we're going to take a third of it. So divided by 3 is another way of looking at that. Okay, so you could also think of this as base times height divided by 3. It's the same idea. Whatever is easier for you to throw it into a calculator. All right, so still going to do the same stuff. Shape goes to a point. My formula is 1/3 base times height. So I need my base. My base is, it says the volume of a pyramid has a height of 28. I label that. And has a square base of 15 centimeters. So 15 centimeters by 15 centimeters. So there's my visual. We're at a 15 by 15. So if you put that into a calculator, multiply it out, that gets you a 225. It's the area of your base. So we just shove it right into our formula. So 225 times your height of 28 divided by 3. It's probably your easiest way to throw that into a calculator. So, I don't know. Let the calculator do the math. So we got 225 times 28 divided by 3. Good. Don't have to worry about rounding. 2100, and it's a volume, so it's a cubic measurement. Okay. So if it was a cone, same thing. The only difference is you'd have a circular base to it, so we would be doing pi r squared to find that value, and then we would still do the same math from there. The only other shape that we have is a sphere. So a three-dimensional circle, a ball, and it has its own formula, and it is not like the others because it's a circle and it's a three-dimensional circle. So it is 4 pi r cubed divided by 3. Don't worry about where that comes from. That's just your formula of it. So there's nothing special, nothing fancy about it. It literally, the only measurement you need is the radius, and you just plug it into the formula. So usually spheres are very straightforward types of problems. There's not a whole lot of extra side work that we had to do, nothing like that. It's just figure out what the radius is, and if you have the radius, you're good to go. Well, they don't give us the radius. They give us the diameter. So if the diameter is 90, the radius is half of that, 45. And that's all you need. So volume is 4 pi r cubed over 3, which is 4 pi times 45 cubed over 3. So it's probably going to be pretty big, because 45 times 45 times 45, just that alone is going to be pretty big. So then you're going to multiply by 4, then you're going to multiply by pi. So the divide by 3 is not going to drastically bring it down. So we have 4 pi times 45 to the third, and then divided by 3. It's a whole lot. So we got, put a comma there, so 381. It doesn't tell us where to round. So again, if it doesn't tell me, I'm just going to cut it off at 2 places. So I want to make that a 5, 1 on there. So 381, 703.51 cubic centimeters. So to be honest, I feel like sphere is one of the uglier formulas, but it's one of the faster problems because, like I said, there's not a lot of side work to it. There's no side work to it. You just shove it into a formula. Done. Okay. So I think last of the volume is yes. So the last of the volume is this thing. So this is a solid cast iron object. So it's solid within it. And we would like to know how much material we got going on. All right, so there's a weight associated to it. So it says find the weight of the solid cast iron object shown. If the cast iron weighs 0.26 pounds per cubic inch. So if we're going to find the volume, we're going to find the cubic inches. And then we can multiply it by the 0.26 pounds. See how heavy the thing is. All right, so round to the nearest whole pound here eventually. So my rounding really kind of won't totally happen until the very, very end. All right, we got to organize our thoughts here. How many different shapes do we need to find? What are they? What shape on top? We got a what?
Cone.
Cone.
A cylinder.
Cylinder.
And half a circle.
Yep, half a sphere. So we need to find the volume of 3 different shapes. We have everything that we need for all 3. And then once we have the shape, the volume for all 3, we'll add them all together. And that'll give us our cubic inches. And then once we know how many cubic inches we have, it weighs almost 1/4 pound per cubic inch. So then we multiply that together and figure out how much the thing weighs. So let's start with the cone. All right, our volume of a cone, it goes to a point, which means it's 1/3 the area of the base times the height. The shape of your base is a circle. So let me do a little side work. How big is that circle for the base of your cone? What is the radius right there? And where do you pull that information from?
4.5.
Yeah, it's basically, here's the diameter going all the way across. That measurement right there is 9. So that puts this thing at a 4.5. Okay, so the area of, so that is the area of the base for both the cone and the cylinder. So the base is pi r squared, which is 4.5 squared. So I don't know what that is. We're going to plug it in the calculator. And I'm going to take it out more. I'm going to take it out probably 2 decimals. Eventually, we'll round it to the nearest whole number. But let me keep some decimal into this to kind of try to keep some level of accuracy going on. But I don't want to go crazy on it. So we'll cut it off at 2. That's hopefully decent. 4.5 squared. So that's our area of the base. Okay, that's not 4.5. So pi times 4.5 squared. So 63.62. Okay, so no matter what, so both of these shapes, I'm going to be using the area of the base. I'm going to keep referring to that value right there. Okay. So here's our cone, area of the base times the height divided by 3. So 63.62 is the area of the base. Times the height. The height of our cone is 8. And we divide it by 3. You don't know, 63.62 times 8 divided by 3. So again, let me cut it off at 2. So 169.65. All right, so there's our cone. On to the cylinder. Cylinder volume is base times height. Top and the bottom match, so we don't have to do the third. So area of our base times our height. Again, area of our base is, we already found, it's the same circle that we just used for the cylinder or for the cone. So that is 63.62 times a height of 10. So multiplying by 10 is just going to bump the decimal over. So that's 63.636.2. So there's the volume of your cylinder. And the last one is the volume of a half of a sphere. So volume is its own deal, 4 pi r cubed over 3. Doesn't have a base on it. All it needs is a radius, which that radius is the same as the radius for the sphere. So 4 pi times 4.5 cubed over 3. No idea. So 4 pi times 4.5 cubed divided by 3. 381.70. So 381. Okay. Oh, I know what I didn't do. Duh. It's half of a sphere. We just found the whole sphere. So we got to take half of that. That's why it felt too big. So I'm going to take that whole thing and divide it by 2. That's better. So 190. All right, now we're good. So we have everything we need. We're going to add our total volume. is 169.65 plus 636.2 plus 190.85. So if you add all of that together, you get 996.7. So if I added all those pieces together, that's how many cubic inches. Almost done though, because there's a weight associated to this. So we're building them, maybe we're shipping them. We need to know how many we have, what the weight of each thing is, so what the total weight might be. So your total volume is this. Your total weight is going to be your 996.7 times your 0.26 pounds per cubic inch. And that's how many cubic inches we have. So we're just going to multiply it by 0.26. So 996.7 times 0.26. So 259. What do they want? Whole pound. Now we're ready to round it. So 259, that's not enough to bump it up. 259 pounds. Well, that's a good one. So it's really 3 problems in one. Find the volume of that, find the volume of that, find the volume of that, add them all together. And then with the little extra, that's your volume, but you have this ratio with the weight, figure out your weight. Okay, so that was volume. Last bit is surface area. Surface area's got all sorts of fancy formulas. I am more of a, let me just break the thing apart and add the areas together. But if you are a formula person, great. I mean, you're going to be able to use the formulas. You don't have to memorize them by any means. You can refer to your notes on all this stuff. There's a little bit of language I want to make sure that you're familiar with, because they do ask for 2 different types of surface areas. One is known as the lateral surface area. So the lateral surface area, just so you know, versus the total surface area, it's going to be down here. The lateral surface area is just kind of the vertical part to it. All right, so your lateral surface area does not include top and bottom. Okay, that's the biggest thing. Doesn't include the top and the bottom. So, so they have a formula. The formula is the perimeter. So the perimeter of the base is the bottom, but it's really the same as the perimeter of the top, times the height. Okay, well, I don't love it because I just don't understand it. So I get that that's a shortcut and whatever. Please use it if you want to. I look at it a little bit different. I want to make sense of my answer. And so if I'm finding the lateral surface area, I'm just going to break those 2 pieces apart and find the areas of them and add them together. So this is the way I do it. Now, could I do the perimeter? Of course. The perimeter is 24, 12, and then you'd have another 24, and you'd have another 12, and then times the height. That's great. It's a quick shortcut thing. It just doesn't mean anything to me. So I just break it up like this real quick. I have this front side is one of the sides, and it's 24 by 20. And I'm going to have 2 of them, because I'm going to have the front and I'm going to have the back. So I'm going to take whatever that area is, I'm going to times it by 2. Then I have kind of the left and the right over here, which is 12 by 20. And I'm going to have 2 of those. That's it. I'm going to find the area of that, double it, find the area of that, double it. So the area of a rectangle is length times width. So 20 times 24 is 480. and I have 2 of them. So that makes 960 if I double that. So 960 of the front and the back together. And then the sides are 12 by 20, which is 240. 2 of them is 480. So my lateral surface area, which again just does not include the top and the bottom, is 960 plus 480. And it's an area measurement, so it has to, even though it's on a 3-dimensional shape, it's still an area measurement. So you're still talking about how many square feet, how much wrapping paper we would need to cover that. Okay, if you chose to do the perimeter thing, totally good. You would just need a little side work of what is the perimeter. So you got 24 plus 24 plus 12 plus 12. And then so you get a 48, 60, 72. And so then they're saying that you could just find that by doing the perimeter times the height. So the lateral surface area would be 72 times 20. And if you multiply that, you get the same 1440. That may be quicker. I just don't love it because I just don't see the pieces going together and way more visual. So I just break up my pieces and make sure I cover everything and add them all together in the end. So I'm typically not finding areas of crazy shapes. I'm finding areas of rectangles or triangles. Maybe a circle every once in a while. Okay, so that's your lateral surface area. The only thing extra is total surface area, which really means you find your sides and then you add the tops and the bottoms to it. That's what this is. So that's your lateral surface area. And then you have a top, 2 tops and bottom, like a top and a bottom. So you find the area of one of them and double it. Okay, so again, I just don't do it that way. I just break up my pieces and see what I got. So total surface area of this triangular prism. So I have a top and a bottom. Your triangles. That is the perpendicular to this. So that's 2.6. Base is 3. So I'm going to find the area of that. And I know that there are 2 of them, because there's a top and a bottom. So area of that is half base times height. So half times 3 times 2.6. 3.9. But there are 2 of them. So I'm going to times that by 2 and get 7.8. So that's the area, total area for the top and the bottom. Then I got rectangles, and I have 3 of them. And every one of these sides is exactly the same. So that means every one of the rectangles is exactly the same. And they are 3 by 15. 3 by 15 is 45. So each one of these is 45 square centimeters, and we have 3 of them. Which when you multiply 45 times 3, you get 135. So my total surface area is 7.8 for the top and bottom, plus 135 for the rectangles. So if I throw that in the calculator, I get 142.8 centimeters. So again, you are welcome to use that formula. Again, I just don't love it. I like to create it and see it and make sense of all the pieces that I got going on, as opposed to just relying on a formula that I don't know if my answers seem right or not. Okay, last page. Cool. One that's a little bit tricky is your cylinder. Just to try to make sense out of the pieces. So I think of it like a Campbell soup label, that this lateral side that I got to try to figure out is basically, there's a cylinder. So if this is my cylinder, the lateral is kind of this piece standing up here. Well, it's actually a rectangle when you cut it and unfold it. So the trickier part is, how long is that? Because the height's going to be very straightforward. The height's the height. But this piece is the piece that's rolled up. That is the circumference of your circle. So when I draw my picture, I'm going to be finding the circumference of that. And then there's my height when I do my rectangle. Okay, that's one that gets a little tricky. So I have a rectangle. The height is 9, and the width is the circumference. So this is 2 pi r, if you want to kind of remember a formula to it. So it's 2 pi times 4.5. Right, so that makes the other dimension for my rectangle. So I'm just going to do length times width. So my area for that thing is going to be 2 pi times 4.5. So that thing times 9. So the width times the length. So if I throw it on the calculator, we are looking to, let's see. It says how many square centimeters of sheet metal are required to manufacture a can. So soda can. It has a radius of 4.5 and a height of 9 centimeters. Assume no waste or overlap. Impressive. And round to the nearest square centimeter. So we're going to round to the nearest whole number here in the end. So if I throw that in the calculator, I'm going to leave a little bit of decimal on it. So that comes out to be this when I put it into a calculator. So that is my rectangular kind of Campbell soup label side. And then my other are the tops and the bottoms, which I have 2 of, which we know the radius to be 4.5. So that is 2 pi r. Nope, sorry. That's an area. Pi times 4.5 squared. And then whatever we get for that, we're going to multiply it by 2 because there's a top and a bottom. So if we throw that all in a calculator, that comes out to be 127.23. So then my total surface area is the combination of the two. That one plus this one. All right, so that adds up to 381.7 because the 7 and the 3 make 10, so we'd round it and get you that. But we want to go to the nearest square centimeter, so that 7 is going to bump that up. 382 square centimeters. So the cylinder is a little bit tricky. Top and the bottom are pretty straightforward. You're looking at circles, but the side unfolds into a rectangle. The height is straightforward, but the width is a circumference of that circle wrapped around. Okay. All right, 2 last shapes. We got like a couple more minutes. We may not get all of it, but we'll get to at least one, maybe start the other. So one other last shape is, second to last shape is a sphere. Sphere, again, is its own world all the way around. It has its own formula. It is 4 pi r squared, and that's it. There's no extra side work that we had to do on this. It's just know the radius, plug it in, you're good to go. And again, they give us a diameter, which we cut in half to do our radius. So our surface area is going to be 4 times pi times our radius squared. So if you throw that into a calculator, that comes out to be 25,446.9 centimeters squared. So spheres are, like I said, spheres are really the most straightforward ones. They're just a formula, no side work, no nothing. Just shove it in the calculator, good to go. You just gotta know the formula. All right, the last one, which is kind of similar. There's a little bit of a difference on this, where the cylinder one, you had to kind of unfold and you had a circumference associated with it. The cone is a little bit different too, that the lateral area, which is kind of this part of it, but it's a cone. The lateral area has this formula to it. So rather than it being pi r squared, it's pi r times s. S is a slant height, not a true height, a slant height. So S equals slant height, which should be given. You shouldn't have to go find it or anything. You just got to recognize that you have a slant height. Okay, so your lateral area is kind of this part of it, not the bottom, and it's just that formula. And then your total is the lateral area plus the bottom. Bottom is just a circle. Okay, so let me at least just do the slant height one, and then we'll finish it up. We'll do the lateral surface area real quick. Okay, so find the lateral surface area, the total surface area of a cone that has a diameter of 8, which means a radius of 4. I really need that. Has a height of 6 and a slant height of 7. So I'm going to be using the slant height, not the true height. The true height we would use if we were finding the volume. All right, so for our lateral surface area, our formula is pi times the radius times the slant height. So pi times the radius of 4, slant height of 7, throw it in a calculator, which makes 87.96. Okay, so I just throw it in a calculator, that's what will come up. Then the base, the bottom, is a circle with a radius of 4. So then that area is pi r squared. So pi times 4 squared. So that's 16 times pi, which makes 50.27. And then my total surface area is just the combination of the two. So 87.96 plus 50.27. Add those up, round to the nearest hundredths. Good thing I already started doing that. Oops. 138.23 cubic. Nope. Square centimeters. That's it. There's a lot. So please keep these notes. Make sure that you refer to formulas and things like that. You do not have to memorize it. I don't want that at all. I just want to make sure you can use it and understand the math that you're kind of doing behind it. Okay, so at no point do you need to memorize. Refer to the notes, look back, look at examples. Strongly encouraged. We'll make sure you have enough time to do that sort of stuff during quizzes and tests and things like that. Okay, the math is itself tough. Like, that's the challenge. It's not the formula part. Okay. All right, sorry, I went a minute over, and we normally don't last this long. So, but hopefully give stuff a shot. You have homework that's due tonight. You got 2 of them, 17.1, 17.2. Please make sure you take care of that stuff. And again, if you need a little bit more time on things, please let me know, reach out. Obviously, it's never a problem. So, all right, we'll see you guys on Wednesday, because this is only Monday. Cool.
Great, thanks.
Well,
Bye,
thank
guys.
you.
Have a good one.
Nice.
Thank you.
Have a good one.
You as well.
Thank you.
You're welcome.